Hello students, you are welcome to MS High EduTech online home lesson. This is a place we prepare you for great excellence in future. This is module 3 and it has been so exciting. We have gone through module 1, module 2, and this is module 3 for junior secondary school. I believe you are going to learn a lot in this module, because this module is very loaded. Okay, my name remains the same. My name is David, your best friend. Okay, today we want to start module 3, and this module 3 we are going to consider some basic topic that are going to help you in future, and we are going to look at expansion. We look at binary system. We also look at simplification of algebraic expression, and many more. I'm going to tell you more. But for the purpose of today, being the first day in this module, we are going to consider binary system. Binary system in advanced form, because if you have been following us from module 1, in module 1 you can see that I explained what binary is all about. We did addition of binary, multiplication of binary, conversion of binary from base 10 to base 2, and from base 2 to base 10. But today we want to really center on how to convert binary numbers from base 10 to another base, then from one base to another. So get ready as we start this topic. Now I need to refresh your brain. Binary numbers is 0 and 1. We call these binary numbers because they are in base 2, is 0 and 1. Now let's look at how to convert from base 4 to another base. How can we convert from base 4 to another base? Let's see this example. Convert 1011 base 2 to denary, that is base 10. Okay, now let's look at this question together. 1011 base 2. Now from here, from your right hand, start numbering it from 0, 1, 2, 3. Okay, pick this one, multiply it by 2, plus pick this 0, multiply it by this 2, plus pick this one, multiply it by this 2, plus the last one, multiply it by 2. Okay, now on top of these 2, we are going to put this value is 0, 1, 2, 3. 0, 1, 2, 3. Okay, now this will give us 1 times 2 times 2 times 2, plus 0 times 2 times 2, plus 1 times 2, plus 1 times 1. Because this is power of 0. Any number or letters that you see 0 as the power, it will be equals to 1. Just like n raised to power 0 equals to 1. Okay, now 2 times 2 will give us 4. 4 times 2 will give us 8. 0 times 2 will give us 0. 0 times 2 will give us 0. Okay, 1 times 2 will give us 2, and 1 times 1 will give us 1. So we have 8 plus 2, 10, plus 1, 11 base 10. Okay, now this is telling you that we convert base 10 to denary, and is the same thing as what? As base 10. That is base 2 to denary. Okay, now let's move to another example, which might look so a little bit difficult for you, but I'm going to make it very simple for you. Just follow me as we solve this example. Finding unknown in binary system. Example, find the value of y if y base 2 times 101 base 2 equals to 110111 base 2. We don't know the value of this y, so that is what we are looking at. Now, let's solve this together. Remember, you have to be patient and follow me, and let's do it together. Okay? Solution: y raised to power 2 times 101 base 2 equals to 110111 base 2. This is 0, 0, 1, 2. Starting from here is 0, 1, 2, 3, 4, 5. Okay? Now, what are we going to do now? Y times 2 raised to power 0 times, okay, 1 times 2 raised to power 2 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0 equals to, this is 1 times 2 raised to power 5 plus 1 times 2 raised to power 4 plus 0 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 1 times 2 raised to power 1 plus 1 times 2 raised to power 0. Are you following me? Okay. 1 times 2 raised to power 0 will give us 1. 2 raised to power 0 will give us 1. So we are going to have y times 1 times 2 will give us 1 times 4 plus this one will give us is 0. 1 times 2, 2 raised to power 0 is 1. 1 times 1 will give us 1 equals to 1 times 2 times 2 times 2 times 2 times 2. Okay. Now 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 will give us what? 32. So this will give us 1 times 32. Okay, so when you do this, 2 raised to power 5 will give us 32. That is 2 times 2 times 2 times 2 times 2 in 5 places. Then 1 times 2 raised to power 4. That means this is not 2 times 4. This is 2 in 4 places, which will give us 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2 will give us 16. 0 times 2 raised to power 3. You know, anything that you multiply by 0 must give you what? Is 0. Okay, this will be 1 times 2 raised to power 2. 2 raised to power 2 means 2 times 2, which is 4. Then 1 times 2. Then 1 times 2 raised to power 0. It will give us 1. Now let's add y times 4 plus 1. It gives us 5 equals to 1 times this 32. 1 times this 16 plus 4. 1 times 2, 2. 1 times 1, 1. Okay, 5 times y will give us 5y. 32, 16 plus 4 will give us 20. 20 plus 32 will give us 52. 52 plus 2 will give us 54. 54 plus 1 will give us 55. So we have 55. So what are we going to do now? Divide both sides by 5. Divide this by 5. Y will give us 55 all over 5. 5 here, 1. 5 here, 1. 5 here, 1. So y will give us 11. So I believe you understand. So this now will now be substituted by what? 1, 1. Are you getting me now? Okay. So this will be the value of y. Now let me give you another example. Converting from base 4 to base 2, and you know that base 2 is binary, right? What are we going to do? We first convert base 4 to base 10. Then from base 10 we can convert to binary, which is base 2. Now let's do it together. We have 162 base 4 is 0, 1, 2. So you convert this to base 10. 1 times 4, not 2 again, times 4 raised to power 2 plus 6 times 4 raised to power 1 plus 2 times 4 raised to power 0. So this will give us 4 raised to power 2 means 4 times 4, not 4 times 2. Please take note of that. Plus 6 times 4 plus 2 times 1. You get it, right? Okay, 4 times 4 will give us 16. 6 times 4 will give us 24. And 2 times 1 will give us 2. Okay, so what are we going to do here? We add this together. 24, 16. 4 plus 6 will give us 10. Is 0 carry 1. 2 plus 1 will give us 3. 3 plus this will give us 32 base 10. Okay, now this is not where we are going to stop, because we are converting to base 2, which is binary. We have to convert 32 base 10 to base 2, which is binary. So what are we going to do? Just do this. 32. Since we are converting to base 2, you use 2 to divide everything you have here. How many 2 can we get in 3? 1. Remainder 1. That 1 that remains, put it at the front of these 2. You are going to have 12. How many 2 can we get in 12? Is 6. Remainder 0. Okay. How many 2 can we get in 16? Is 8. Because 2 times 8 will give us 16. Remainder 0. How many 2 can we get in 8? Is 4. Remainder 0. How many 2 can we get in 4? Is 2. Remainder 0. How many 2 can we get in 2? 1. Remainder 0. How many 2 can we get in 1? Is 0. Remainder 1. So you start from the bottom. You are going to have 162 base 4 equals to 1, 1, 2, 3, 4. 1, 2, 3, 4, 5. Base 2. This will be your answer. Now let me tell you something. You can apply this method on any question once you are converting from one base to base 2 or binary. Now if I give you another example, now time will not permit me, I can give you an example and you can also try it at home. Converting 120 base 5 to base 2. You can still apply this method, you will still get your answer. Okay, now let's see how to convert from one base to another. Let me give you another example. Okay, now we have solution here. 1278, that is 127 base 8. You put 0, 1 and 2. Okay, 1 times 8, you put the 2 plus, pick the 2. 2 times 8 raised to power 1 plus 7 times 8 raised to power 0. So 1 times 8 raised to power 2 will give us 8 times 8, not 8 times 2, plus 2 times 8, then plus 7 times 1, because 8 raised to power 0 is 1. Okay, 8 times 8 will give us 64. plus 2 times 8 will give us 16, and 7 times 1 will give us 7. So let's add together. We have 64 plus 16. 4 plus 6 will give us 10. Is 0, take away 1. 6 plus 1 will give us 7. Plus 1, 8. And you know we have 7 here. Plus 7. 0 plus 7, 7. 8 will come down. We have 87 base 10. But this is not our last solution. Remember, we are converting to base 4. So what are we going to do? You do like this. 87, 4. Not 2, because we are not converting to binary. It's base 4. Okay? How many 8 can we get in 8? It's 2. Because 2 times 4 is 8. How many 4 can we get in 7? Okay? It will give us 1. 4 times 1 is 1. Remain 3. Remainder 3. Okay? Now let's look at 4. Now, how many 4 can we get in 21? You think of number you can multiply by 4. That will give you 21. There's no number like that. So let's think about 5. 4 times 5 will give us 20. So 5, remainder 1. Now let's use 4 again. How many 4 can we get in 5? It's 1. Remainder what? 1. 4 again. How many 4 can we get in 1? Nothing. Is 0. Bring the 1, bring it down. So from bottom we have 127 base 8 equals to 1113 base 4. Okay? Now you can also apply this method in converting. Just imagine that you set a question by yourself and you put 125 base 8 to base 4. You still get the same answer. Or you give yourself a question 134 base 5 to base 4. It's still the same method you are going to use. So don't get confused with that. We have come to the end of this class, and I still want to remind you that this is the beginning of this module 3, and you need to be very serious about it, because at the end of this module you are going to write online exam at the comfort of your house. And if there's any question or you have any point of clarification, you can send a message to us through the WhatsApp number rolling on the screen, and I believe that we are going to give you the best. Okay, now before we round up this class, I have to give you something to keep you busy until we meet next class. Are you ready for that? Okay, now let me give you something to keep you busy. Now let's look at this homework. Okay class, this is homework for you, and I believe that you are going to do it very well, right? Question number 1, express 110111 base 2 in denary. Number 2, express 120 base 5 in base 4. Number 3, find the value of P if P base 2 times 1011 base 2 equals to 01111 base 2. Then the last one, express 128 base 10 in base 2. Thank you very much for your patience and for being with us. MSI EduTech online home lesson. We are preparing the best for you. See you next class. Au revoir.